All right, let's go ahead and do a little bit of a review on lab math. Specifically, we're going to be talking about dilutions because you're most likely to make dilutions in the serology laboratory. So let's get started. So it's often necessary to make dilutions of specimens being analyzed or to make weaker solutions from stronger solutions in various laboratory procedures. Clinicians must be able to work with various dilution problems and dilution factors. They often need to determine the concentration of antibody in a solution. That's very often what we're doing in the serology lab. The actual amount of material in each solution and the total volume of each solution. All these dilutions are a form of a ratio. Dilution is an indication of a relative concentration of something. Why make a dilution? Well, we're going to make dilutions because we may have to make up reagents. So a lot of times in the kits that you're using in serology, you have to dilute up things like the buffer solution, okay? Or if you want to find an antibody titer, let's say you're reporting out a titer of cryptococcus in spinal fluid, you'd want to find the antibody titer by making a serial dilution. And sometimes you need to dilute up samples if they're above linearity. A good example of that is if you have a glucose that's above linearity of the instrument, you might have to make a dilution of that and then take it times the dilution factor once it's reran. And then finally, if you only have a limited amount of sample that's available, you might have to make a dilution to use smaller volumes. So those are all different reasons why you may need to make a dilution. A dilution factor is used to correct for having used a diluted sample in a determination rather than an undiluted sample. The result, or the answer, using the dilution must be multiplied by the reciprocal of the dilution made. So in this example up on the screen here, if you have a glucose that is above the linearity of the instrument, for example, you run a glucose and it's, say, 700 and the linearity only goes up to 400. You might want to make a 1 to 2 dilution of that, okay? So you're going to take one part of serum and one part of diluent and rerun it on the instrument. So let's say you rerun it on the instrument and you get a value of 380, okay? So you would take that 380 and then you would correct using a dilution factor. You would actually multiply that times 2 to give you the accurate glucose value. So if you take 380 times 2, let me just calculate that real quick. That gives you a glucose value of 760, which of course is a critical value. A dilution factor by which all determination answers are multiplied to give the concentration per 100 mils of sample may be calculated like this. First, determine the volume of blood as is actually analyzed in the procedure. Using a simple proportion, it is evident that 0.5 mils of blood diluted to 10 mils is equivalent to 1 mil of blood diluted to 20 mils. Here, the concentration of specimen, which is blood, in each milliliter of solution may be determined by the use of another simple proportion to be 0.05 mils of blood per milliliter of a solution. So here you can see 1 mil of blood over 20 mils of solution equals X mils of blood over 1 mil of solution. Okay, so X ends up being 1 times 1 divided by 20, and that equals 0.05 mils. Because 1 mil of the 1 to 20 dilution of blood is analyzed in the remaining steps of the procedure, 0.05 mils of blood is actually analyzed. 1 mil of the dilution used times 0.05 mils equals 0.05 mils of blood analyzed. To relate the concentration of the substance measured in the procedure to the concentration in 100 mils of blood, another proportion may be used, and you can see that calculation on the slide here where we end up getting the concentration desired is 2,000 times the value determined. The concentration of the substance being measured in the volume of blood actually tested, which of course was 0.05 mils, must be multiplied by 2,000 to report the concentration per 100 mils of blood. The material must be summarized by the following statement and equation. In reporting results obtained from laboratory determinations, one must first determine the amount of specimen actually analyzed in the procedure, and then calculate the factor that will express the concentration in the desired terms of measurement. Thus, in the previous sample, the following equations were used. 0.5 mils over 10 mils, that's the volume of blood used over the volume of total dilution, equals the volume of blood analyzed, which is X, over 1, which is the volume of dilution used. If you solve for X, X equals 0.05 mils. That's the volume of blood actually analyzed. 100 mils, which is the volume of blood required for expression of result, divided by 0.05 equals 2,000, which is the dilution factor. Now, rather than doing ratio and proportion, I think an easy way to calculate dilutions or finding the amount of serum that you need to use in a dilution if you don't have a full mil is to just do the calculation that I have showing here. So let's say you only have 0.3 mils or 300 microliters of serum, okay? And let's say you need to make a 1:40 dilution. Well, it's best if you can bring the math up to 1. It makes life a little bit easier. So if you have a 1:40 dilution that you're trying to make with 0.3 mils of serum, we've got 1 part and 39 parts. So we're going to take both sides. We're going to take 1 and multiply that times 0.3. And we're going to take 39 and we're going to multiply that times 0.3. So in this example, we would use 0.3 of serum and 11.7 mils of diluent to make a 1:40 dilution. And you can do that with any number. So let's say you only have 0.5 mils you would take, and you want to make a 1:20 dilution. You would take 0.5 times 1, and then you would take 0.5 times 19, and that would give you your total for serum and what you need for diluent to make a 1:20 dilution. I'll give you some examples on a sheet to calculate on your own. When the concentration of a particular substance in a specimen is too great to be determined accurately, or when there is less specimen available for analysis than the procedure requires, it may be necessary to dilute the original specimen or further dilute the initial dilution. These single dilutions are usually expressed as a ratio, for example 1:2 or 1:5 or 1:10. Sometimes you'll see it expressed as a fraction. These ratios refer to 1 unit of the original specimen diluted to a final volume of 2, 5, or 10 respectively. A dilution therefore refers to the volume or number of parts of a substance to be diluted in the total volume, or parts of the final solution. A dilution is an expression of concentration, not volume. It indicates the relative amount of substance in a solution. So substances in a dilution can be made singly or in a series. So to make a single dilution, we have an example here below. Okay, a specimen contains 500 milligrams of substance per deciliter of blood. A 1:5 dilution of the specimen is prepared by volumetrically measuring 1 mil of the specimen and adding 4 mils of diluent. The concentration, denoted as C in the below equation, of substance in the dilution is calculated as follows. C equals 500 milliliters per deciliter times 1/5 equals 100 milligrams per deciliter. Okay. Note that the concentration of the final solution is expressed in the same units as that of the original solution. To obtain a dilution factor that can be applied to the determination answer and express it as a concentration per standard volume, proceed as follows. Rather than multiply by the dilution expressed as a fraction, multiply the determination value by the reciprocal of the dilution factor. In this case, a 1:5 dilution, the dilution factor is going to be 5 because the original specimen was 5 times more concentrated than the diluted specimen tested in the procedure. Serial dilutions are a method for determining the concentration of a substance in a solution. Usually in serology lab, we are looking for the concentration of antibody. The greatest dilution of the sample that yields a positive result is your endpoint. The endpoint dilution can be expressed as a fraction. The reciprocal of that fraction is called the titer of the antibody. If you have a series of dilutions in a sample serial dilution scheme, you can actually take the reciprocal of the titer and multiply that times your tube dilution to get the final concentration of antibody. So in this case here, in this example here, we have a series of 5 tubes. And in the first tube, we've got 1 ml of saline, so that's one part, and we've got 1 ml of serum. So because we have equal volumes or equal amounts, we have a 1-to-2 dilution. Okay. If we transfer 1 ml to the next tube, we still have a tube dilution of 1-to-2. Okay, so we have 1 ml of serum still and 1 ml of saline, so our tube dilution is 1-to-2, but our concentration of antibody in that tube would be 4 times 2. Okay, or I'm sorry, 2 times 2. And in the third tube, after we've serial diluted, we still have the same tube dilution, which is 1-to-2, and that 1-to-2 is 2 times more concentrated than the 1-to-4 tube, so the concentration in the third tube would be 1-to-8, or it would be 1-to-8 dilution, 1-to-8 titer. A central concept of serological testing is the manifestation of a rise in titer or concentration of antibody. The antibody titer is defined as the reciprocal of the highest dilution of the patient's serum in which the antibody is still detectable. That is, the titer is read at the highest dilution of serum that gives a positive reaction with the antigen. If a serum sample has been diluted 1-to-64 and reacts positive with the antigen suspension used in the testing process, and if the next highest dilution is 128, does not give a positive reaction, then your endpoint for that titer is 64. Now, dilutions even get a little bit more complicated after we add antigen, okay? So let's go ahead and discuss how to figure out our tube dilution, our serum dilution, and our serum dilution with antigen, okay? So if I tell you to get a series of 5 tubes and then take tube 1 and add 0.9 mils of saline to it, and then tubes 2 through 5 have 0.5 mils of saline in them, and then we add 0.1 mil of serum to tube 1, and then transfer 0.5 mils of serum from tube to tube and discard 0.5 mils of serum from tube 5. And now that doesn't change the concentration, that only changes the volume, okay? But for continuity, we're going to discard that 0.5 mils out of the last tube. Then we're going to go back and add 0.5 mils of antigen to each tube. So how do we go about figuring out the tube dilution and the serum dilution with antigen? I like to draw it out. I need to be able to see what I'm doing when I am creating serial dilutions. So I actually draw it out so I can see it. Okay, so in the first tube, if I have 0.9 of saline and 0.5 of diluent, then we have a 1-to-10 dilution. Okay, if we transfer 0.5 from that first tube and move it over to tube 2, we essentially have the same volumes, because remember, we started with 0.5 of saline and now we're adding 0.5 of our original tube serum. Okay, so that tube dilution is still 1-to-2. Okay, so every tube is going to be 1-to-2 from here on out because we're transferring 0.5 into tubes that already have 0.5 of saline. Okay, now our serum dilution in tube 1 is still 1-to-10. We have 9 parts of saline, and we have 9 parts of saline, and then we have 1 part of serum. Okay, so we still have a 1-to-10 solution in tube 1. Now our serum dilution in tube 2, because our tube dilution is 1-to-2, we can take our 1-to-10 serum dilution and multiply that times 2, giving us a 1-to-20 tube dilution. A 1-to-20 serum dilution in tube 2. Okay, tube 3 is 2 times more concentrated than tube 2, so our serum dilution is 1-to-40. Tube 4, it's 1-to-80, and tube 5, it's 1-to-60. Okay, now the confusing part. So we've essentially removed 0.5 mils of volume from all of our tubes, and now we're going to add back 0.5 mils of volume of antigen. So we are further diluting every tube times 2. So our first serum dilution tube with antigen would be 1-to-20. It's actually 2 times more concentrated than it was before we removed 0.5 mils of serum and added back 0.5 mils of antigen. Okay, so tube 2 is going to be 1-to-40. Tube 3 is 1-to-80. Tube 4 is 1 to 160, and tube 5 is 1 to 320. But like I said, the best thing you can do is actually draw this out so you can see what volumes of saline or diluent were in the tubes to start with, what volume of serum went into that first tube, and how much of the previous tube is transferred to all additional tubes in the series. So draw that out and you should be able to figure this out. And then just for kicks, I decided to add a V1C1 review for you. So here's an example. If you want to make 5 mils of a 0.25 molar solution from 2.5 mils of a 1 molar solution, you would use V1C1. So here we have got 1 molar equals 5 mils times 0.25 molar. V1 equals 5 mils times 0.25 divided by 1. And so our volume 1 equals 1.25 mils. Okay, and I'll give you some other examples to view this with as well. So that's a little bit about dilutions. Hopefully this has been a good review for you since your intro class.